Let's look at our final type of indeterminate form. We have an infinity minus infinity indeterminate, and we're asked to find the limit. We're going to find the limit as x approaches 2 from the right for 8 over x squared minus 4 minus x over x minus 2. The first fraction has a denominator that's a difference of two squares. That will factor as x plus 2 times x minus 2. The second fraction has the x minus 2 factor, but it does not have an x plus 2 factor. Let's multiply that into the top and bottom. By creating a common denominator, we can merge these two fractions into one, and hopefully we can build an infinity over infinity or 0 over 0 case where we can use L'Hopital's. As we merge these two fractions into one, the common denominator is x plus 2 times x minus 2. Across the top, we have 8 minus x squared minus 2x. Rearranging the order, that's negative x squared minus 2x plus 8 over x plus 2, x minus 2. Excuse me. I'm going to factor a negative out. It makes it easier to factor the numerator. So I'm going to change all three signs by factoring the negative out. That leaves us with a trinomial on top of x squared plus 2x minus 8. That will factor as x plus 4 times x minus 2, leading to cancellation of a factor from top and bottom. Being able to cancel that factor out leaves us with a case where we no longer have an indeterminate or even an undefined case. If we substitute 2 in for both of these x's, that's going to give us 6 over 4. Don't forget your negative out front. And so we have a limit of negative 3 halves. Below there's a small, I don't want to say chart, but I copied this out of your e-text. There are certain forms that are not indeterminate, and they should be recognized as determinate. One case is if you have infinity plus infinity, negative infinity minus infinity, 0 to an infinity, or 0 to a negative infinity. Just be careful, these are not indeterminate forms. The forms we've looked at, back up to your top left, 0 over 0, infinity over infinity, these are direct cases for L'Hopital's rule. These other indeterminate forms that we've investigated, you need to get them in the format of the first two if you plan to use L'Hopital's rule. Let's also remember these last three that have exponents. We let y equal our original limit, and then we take the natural log of both sides so that we get the exponent to come down to the base level. Then we do a little algebra manipulation. If we can reach one of these two formats, then we use L'Hopital's rule. Sometimes we have to use L'Hopital's rule more than once, but use L'Hopital's rule. And then once you get your limit, though, for those last three, once you get your limit, remember you have to exponentiate with an e so that you turn your natural log y statement equals whatever numerical value you came out with back into just y because y was the original limit. As a final comment, remember that L'Hopital's rule can be applied only to quotients leading to the indeterminate form 0 over 0 and infinity over infinity, and that there are cases where it looks like you can use L'Hopital's, but it's erroneous to use it. For example, below the limit as x goes to 0 for e to the x over x, it's very tempting to say e to the 0 is 0. Now, the denominator is clearly 0, but when you take the derivative, you get e to the x still stays on top. The derivative of x is 1. That's your bottom. But the problem is that's not 0 over 0, so it's incorrect use of L'Hopital's.